In this last example here, this was a function according to the definition here, and I wanted to just say a couple things about it. Each of these input values is assigned to one and only one output value, and so that's why this is a function. When we do have a function relationship between two variables, in this case, we would say that the distance traveled is a function of the time of travel. So I wanted you to see that in general. Again, we say the distance traveled is a function of the time of travel regarding this situation. In general, when there is a function relationship between an input and an output variable, the general rule or wording is that the output variable is a function of the input variable, whatever they are. So in general, this statement we want you to be familiar with. The output variable is a function of the input variable, whatever they are. All right, let's look at number 2. So be aware of that in your reading of this section. Let's look at number 2. Does this table represent a function? Same variables here, time of travel, we'll say in hours, and distance traveled in miles. So the idea is that in order for this to be a function, each input value must be assigned to one and only one output value. While here, 2 is, that input value is assigned to one output value, 10. It's not like 2 is assigned to another value somewhere else on the table. And if you go through this, you'll see that each of these are assigned to one and only one, except for this one. Look at 12. 12 is assigned to 60, and 12 is assigned to 70. So here's our violation of our definition here. And so does this represent a function? Hope you're saying no, because this input value of 12 is assigned to more than one output value, 2 to be in fact. So to answer the question, we say no, since the input value 12 is assigned to more than one output value. And so that will suffice for an explanation there. So again, just trying to show you the definition of a function and how to apply it.